Good morning. Today we're going to do 10-4. This is page 309. We're doing 309 to 311 in our packet. There are 4 problems on this page. And what we're doing now is finding the roots. Now, this is something we did way back in chapter 7. But now we can find the roots, whether they're real or complex. Before, we could not find the complex roots. Okay, so some of these will have all real roots, and that's kind of a review of what we've done in the past. And some of them, there will be complex or imaginary or irrational roots that we were not able to do with some of the methods that we used in chapter 7. Okay, but we start out the same way. Find the roots, both real and imaginary, of each polynomial equation. Remember, our possible roots are going to be the factors of 10. So plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So you plug those numbers in one by one to see which one, when you plug it in, you get 0. Well, I found that P of 1 equals 0. Just double check that. 1 cubed is 1. 2 times 1 squared, so plus 2 minus 13 times 1 plus 10, and we in fact get 0. So I'm going to divide this by x minus 1. Okay, so when I divide by x minus 1, I put a positive 1 in the corner. I'm going to do synthetic division. And I bring down the 1, multiply by 1, add, multiply, add, multiply, add. Okay, so when I divide this thing by x minus 1, I get x squared minus 3x minus 10. So basically what I've done, this thing factors into x minus 1 times this. Okay, and then I think this factors further, x minus 1, x minus 5, x plus 2. And to find the zeros or the roots, we set this equation equal to 0. That's going to find what value of x, make our y value 0, and therefore our x-intercept. So x equals, we've got negative 2, positive 1, and positive 5. So there's our 3 roots or our 3 zeros. Let's try the next one. Okay, now this one, 3x to the 4th minus x cubed plus minus 22x squared plus 24x. Notice there's an x in every term. I'm first going to factor out an x, and then I'm left with 3x to the 3rd minus x squared minus 22x plus 24. Okay, so I know one of my zeros or one of my roots is 0. So setting this equal to 0, this entire thing will be 0 if x is 0. So now I'm going to do the same thing I did up here in the first problem. I'm going to look at the factors of 24, plus or minus 1, plus or minus 2, plus or minus 3. Oh, there's a lot. Plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Fortunately, I've already checked. I know which one works. Oh, you couldn't see all that. I believe 2 works. P of 2, let's just check it out. 3 times 2 cubed is 8. 8 times 3, we've got 24, minus 2 squared, minus 22 times 2, plus 24. Guys, that's going to be 20, negative 24. Up, that works. So now I'm going to take this thing, and I'm going to divide by x minus 2. So I put a 2 up in the corner. Bring down, I've got the 3, the negative 1, the negative 22, and the 24. And bring down the 3, multiply, add, multiply, add, multiply. And there's my confirmation. I get 0, remainder of 0, so this divides evenly. So right now I can factor further. Now this is x times x minus 2 times 3x squared plus 5x minus 12. And do we think that factors further? I don't know. Let's check. What's the discriminant? If the discriminant's a perfect square, then it factors. B squared minus 4ac, that's going to be 25 minus 4 times 3 times negative 12. 25 plus 144. Oh, that's 169. It sure does factor. That's 13 squared. So I've got x minus 2, 3x, and x. I need 2 numbers that multiply to negative 12, add to positive 5. So let's do a 4 and a 3. 3, 4. I think a 3 and a 4 might work. So outers give us 9x, the inners give us 4x. So if it's plus 9x minus 4x, that would give us this, and I think that works. Okay, setting that equal to 0, we can get our roots. So x equals -3, 4/3. Well, let's do an order. -3, 0, 4/3, and 2. That's 4/3, right? 4/3, that's a +2, that's a 0, and that's a -3. Okay, so far this is really just some review from chapter 7. Now let's see this one. So actually this looks like we could factor by grouping, which sometimes that's useful. We've got a ratio of 1 to 3, ratio of 1 to 3. So let's factor out x squared from the first two terms. We've got x minus 3, then factor out a -4, and we've got x. Does that work? Oh, how about a +4? And we get x minus 3. Okay. And we've got x minus 3 as our common factor, x minus 3, and x squared plus 4. Well, isn't that nice? So one of our solutions is 3. And here we would say, okay, well, that doesn't give us any real solutions. But now that we're in chapter 10, we can solve this. We can set that equal to 0. X squared plus 4 equal to 0. So x squared equals -4, which means x equals plus or minus the square root of -4, which is plus or minus 2i. So we get plus or minus 2i. There's our 3 solutions there. Okay, let's go to the next one. Okay, 3x, oh, we got a quartic, so we're looking for 4 solutions. Okay, remember the degree is going to match the number of solutions. So we're looking for 4. This is nice. We know that our zeros, any real zeros or rational zeros, will be factors of 1, so plus or minus 1. There's fewer things to check. Let's try, actually I already checked 1 doesn't work, but -1 I believe works. Let's double check. 3 times -1 to the 4th is 3. 11 times -1 cubed, so minus 11, plus 14, minus 7, plus 1. So that gives us -8 plus 14, 6, minus 7, -1, plus 1. That works. So we're going to divide by x plus 1, which means oh, you couldn't see that. Just so you could see that I actually did get 0. Okay. We're going to divide by x plus 1, so -1 goes in the corner. Got 3, 11, 14, 7, and 1. 4th, 3rd, 2nd, 1st. Make sure you didn't miss any of those degrees as you go down by 1 each time. X to the 4th, x to the 3rd, x to the squared, x to the 1st, and x to the 0. 3 times -1, add those, multiply, add those, multiply, add those, multiply, you get 0. That confirms that this divided evenly. Now we've basically factored this into x plus 1 times 3x. Now notice this just went down by 1 degree, so that's 3x cubed plus 8x squared plus 6x plus 1. Okay, but we can do this again. Let's see if this thing, maybe -1 works again. Okay, let's just double check. That would be -3 plus 8, which is 5, minus 6, -1 plus 1. So I think -1 is going to work again. So we can divide by x plus, this thing by x plus 1. Bring down the 3, multiply by -1, add, multiply, add, multiply, and we get 0. Okay, so this thing, we bring down this x plus 1. This thing divides even by another x plus 1. And what's left is 3x squared plus 5x plus 1. Okay, so we know we've got a double zero. There's going to be a bounce if we were to graph this thing when x is -1. Let's see if this thing factors. Um, let's find the discriminant. B squared minus 4ac. Discriminant is 25 minus 4 times 3 times 1. That's 25 minus 12. That gives us 13, so that does not factor. Okay, but we can find the zeros here by using the quadratic formula. Remember, we're setting this thing equal to 0, so figure out what values of x make each of these factors equal to 0. X equals opposite b plus or minus square root b squared minus 4 times 3 times 1 over 2 times 3. So we get x equals -5, 6 plus or minus rad 13 over 6. Okay, so our roots are x equals -1. I'm going to list it twice just so we know it's a double root. If I asked you for distinct roots, you don't have to list it twice. -5, 6 plus or minus rad 13 over 6. There are your four roots because it's fourth degree. Okay, next page. Now, some of these are just interesting problems. Write the particular equation of a polynomial function that satisfies the given specifications. Sorry, can't see that. Confirm the results by graphing the function on your Inspire. I'm going to leave that to you to graph these on your calculator and confirm. It's a cubic function, which means there's 3 zeros. One of them is x equals -3. And then we've got 2 here. They tell us one is 2 plus I, but these will always come. This is a complex solution, so it will always come in complex conjugate pairs. So the other one will be 2 minus I. Let's find a quadratic with these two solutions first. Okay. Remember, quadratic is x squared minus the sum of the roots times x plus the product of the roots equal to 0. The sum of these two, 2 plus I plus 2 minus I, would be 4. The product of these two would be 2 plus I times 2 minus I. You get 4. Outers and inners cancel, and then you get minus I squared. So that's 4. I squared is -1, so minus -1 gives me +1. The product is 5. So I get x squared minus the sum, 4x plus the product equal to 0. Okay, that's not cubic. I also know I've got a real 0 at x equals -3. So my other factor is going to be x plus 3. So my cubic is going to be this thing times this thing. So I've got x plus 3 times x squared minus 4x plus 5 equal to 0. Let's multiply that out. X cubed minus 4x squared plus 5x plus 3x squared minus 12x plus 15 equal to 0. Combine your like terms. Minus 4x squared plus 3x squared, which gives you minus x squared, plus 5x minus 12x, so minus 7x plus 15 equal to 0. There's your cubic. And you could graph that on your Inspire and confirm that your solutions. Now you'll find a solution as x equals -3. Here you're not going to see a solution there. Okay. But we know you're going to see something that looks something to the effect of, we know the end behavior, since it's odd degree and a positive lead coefficient, it's going to be like that. Y-intercept is 15, so somewhere up there. -1, we said there is, oh no, we don't have a bounce. We're going to cross through when x is -3. Okay, at some point you might see a squiggle, but we know on the left it's going to be down. On the right, going to be up, so maybe it's something like this. I don't know that that's a max, so maybe I don't want to make it look like that because I really have no idea. We don't have enough information for that. Maybe it actually kind of does a squiggle like this. Who knows? We don't know. Okay? But you get an idea. At least you've got the end behavior, you've got your intercepts. Okay, so I'll leave that to you to graph. A quartic function with x equals -2, x equals +1, a complex 0 at 4 plus 3i. So 4 minus 3i is going to be your next one. Okay, let's find the sum. Let's find a quadratic with these two, and then we can multiply it by, this gives us the factor of x plus 2. This gives us a factor of x minus 1. The sum of these two roots, 4 plus 4 is 8. Minus plus 3i and minus 3i cancel out. The product of these two is going to be 4 plus 3i times 4 minus 3i. Multiplying that together, we're going to get 16. Outers and inners cancel because they're conjugates. You get minus 9i squared, which gives me plus 9, or 25. So this is going to be x squared minus the sum of the roots, 8x, plus the product of the roots, 25, equal to 0. Now we can expand this out. So I'm going to actually multiply these two together, the first two. I'll get x squared. So minus 1x plus 2x, so plus x minus 2. And I've got x squared minus 8x plus 25 equal to 0. Okay, now we can multiply this out. X squared times x squared. I'm just going to keep distributing. That gives us x to the 4th minus 8x cubed plus 25x squared. And x plus x cubed minus 8x squared plus 25x. And the last, -2 minus 2x squared plus 16x minus 50 equal to 0. So I've got x to the 4th minus 8x cubed plus x cubed is minus 7x cubed. 25x squared minus 8x squared is going to give us plus 17x squared. And then I've got, did I miss something? X squared, and then minus 2x squared. So that's going to be plus 15x squared. 25, 23. Yep, that looks good. 25x plus 16x gives me 41x minus 50 equal to 0. So there's our quartic. You could graph that on the calculator, and you could at least confirm your real zeros. Quartic function, well, this one positively coefficient and even degree, you could also confirm that it's going to be up and up as the end behavior. Quartic function with these zeros, these zeros and these zeros. So we've got 4 plus 2i, 4 minus 2i, and I've got -2 plus I, -2 minus I. Let's make two quadratics out of these, then we can multiply those together to get our quartic. Here our sum. It's going to be 8. The product is 4 plus 2i, 4 minus 2i. Okay, so that's going to be 16. Outers and inners cancel. Minus 4i squared. So plus 4. That equals 20. So we've got x squared minus the sum of the roots times x plus the product of the roots equal to 0. So these two, the sum of these two roots is -4. The product of these two roots is -2 plus I, -2 minus I, which is -2 times -2 is 4. Outers and inners cancel. We get minus I squared, so plus 1. We get a 5. Actually, let's do this. We get 5. So we've got x squared minus the sum of the roots. So minus -4, so plus 4x plus the product. I'm multiplying these two quadratics together. It's going to give us a quartic function that has all four of these zeros. So x squared minus 8x plus 20 and x squared plus 4x plus 5 equal to 0. Okay, let's multiply. X squared times x squared is x to the fourth plus 4x cubed plus 5x squared. Okay, then the minus 8x times x squared minus 8x cubed minus 8x times 4x minus 32x squared minus 8x times 5, so minus 40x, and then plus 20x squared plus 80x plus 100 equal to 0. Okay, so we've got x to the fourth, x cubed and x cubed. So that's going to be 4x cubed minus 8x cubed is minus 4x cubed, or x squared, 5x squared minus 32x squared plus 20x squared. Let's see. So that's going to be 25x squared minus 32x squared gives me minus 7x squared. That looks right. And then I've got 80x minus 40x gives me plus 40x, then plus 100 equal to 0. Okay. I'm out of space a little bit there. Okay. Use the remainder theorem to quickly find the remainder when the polynomial on the left is divided by the linear binomial on the right. So when we take this and we divide by this, we're going to find the remainder theorem by synthetic substitution and by direct substitution. Okay. So the remainder, when I divide by x minus a, that means I'm going to plug in positive 1. P of 1 is equal to 1 to the fourth minus 5 times 1 squared plus 4. Okay, 1 minus 5, so we get 0, so our remainder is 0. Synthetic substitution is this. When we take, as if we're going to do the synthetic division, we take this and we divide by x minus 1, so we get a positive 1 in the corner. We put our coefficients here. I've got a 1. Now be careful. That's x to the fourth. There's 0x cubed, so I need a 0. There's minus 5x squared, so minus 5x squared. There's 0x, so I need a 0, and then there's my constant. I've got to go down by 1 degree each time. These columns represent x to the fourth, x to the third, x squared, x, and constant. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. Boom. Our remainder theorem, that's our remainder. And that's our remainder. We can do this by synthetic substitution or by direct substitution. Either way, we get a remainder of 0. And that's all we have to do there. Okay. So then one last page. We are skipping this problem because this one does not work. Okay. This is actually not a 0. Okay. So we're going to go down to this one. I'm going to cut that out of the video. 5 minus 7, rad 7 is 1 0 of this. Find the other zeros, which means another one is 5 plus rad 7. Let's try this. So let's do, I don't want to raise that to the fourth. So we're going to do this with the synthetic division. I'm going to take this thing. I'm going to divide by x minus this quantity. Okay, so I'm going to put 5 minus rad 7 up in the corner. Got x to the fourth, 1, negative 10, 19, negative 10, and 18. Bring down the 1, multiply, 5 minus rad 7, add these together. Negative 10 plus 5 is negative 5 minus rad 7. Give myself a tiny bit more space. Negative 10, got 19, negative 10, and 18. So I have to do this times this. So 5 minus rad 7 gets multiplied by negative 5 minus rad 7. So I got negative 25 minus 5 rad 7, that's the outers, plus 5 rad 7, and then plus 7. Those cancel. So I've got negative 18. Negative 18. Add those together. I get positive 1. 1 times 5 minus rad 7. Add these together. I get negative 5 minus rad 7. So again, I'm going to have negative 5 minus rad 7 times 5 minus rad 7. That's the same thing I just did here, and I end up with a negative 18, and I get a remainder of 0. Okay. Now I also know that this is a 0, so I'm going to divide by x minus this thing. 5 plus rad 7. Bring down the 1. Multiply by this. 5 plus rad 7. Well, that gives me a 0. Multiply. Add. Multiply. That gives me 0. That confirms that that divides evenly. This represents, now notice this was a 4th degree. When I divided by a linear, x minus this thing, I got a 3rd degree. I divided by a linear again, x minus this thing, I got a 2nd degree. This is x squared plus 0x plus 1. Okay, setting that equal to 0 is going to give me my other two zeros. I remember we're finding the other two zeros. So I've got x squared equals negative 1. So x equals plus or minus the square root of negative 1, or plus or minus I. So your zeros are 5 plus or minus rad 7 and plus or minus I. There's your 4 zeros. Okay, one last problem. All right, the last one on this page, number 9. We're going to go through this. These numbers are a little bit messy, but it's kind of neat how it works out. So we get this polynomial, which is a quartic. We know that one of our zeros is negative 6 plus 4 rad 3i. So the other one's going to be negative 6 minus 4 rad 3i. Okay, so one of our factors that we would want to divide by is going to be x minus this thing, and then x minus this thing. So we're first going to divide by x minus this thing, which means we're going to put negative 6 plus 4 rad 3i up in the corner. We use our coefficients to do the synthetic division. 1, 4, 13, negative 372, and 2100. Okay, I'm going to write kind of small because there's a lot to this one. Okay, bring down the 1. Multiply by this mess. So negative 6 plus 4 rad 3i. Add those together, you get negative 2 plus 4 rad 3i. This thing times this. Okay, I'm going to go over here and do this. And I've got negative 6 plus 4 rad 3i times negative 2 plus 4 rad 3i. Okay, and I get 12. The outers give me minus 24 rad 3i. The inners give me minus 8 rad 3i. And then the outer, the last 4 times 4 is 16. Rad 3 times rad 3 is 3. So 16 times 3 gives me 48. So I get plus 48i squared, or minus 48. Because plus 48 times I squared is plus 48 times negative 1. Remember, I squared is negative 1, so we get minus 48. Combine your middles, 12. That gives me, actually, the 12 minus the 48 gives me negative 36, adding these two together. And then we can combine these two like terms, minus 32 rad 3i. Okay, so that goes here, minus 36 minus 32 rad 3i. Add these together, I get minus 23. So 13 minus 36 is minus 23, and then bring down minus 32 rad 3i. Now I need this times this, so I'm going to do -6 plus 4 rad 3I times -23 minus 32 rad 3I. Multiply these together, -6 times -23 gives me 138. The outers, -6 times -32 rad 3I gives me plus 192 rad 3I. Inners, 4 rad 3I times -23 gives me minus 92 rad 3I. And then the lasts, I've got 4 times 32, which is 128, times 3, which is 380. What is that? 32. Oh no, I've got, where am I? 32 rad 3I times 4 rad 3. Oh yeah, 4 times 32, that's 128. 128 times 3 gives me 384, and that's negative, and then times the I squared makes it positive, so plus 384. Okay, let me just double check that. Yep, that's right. So combine your like terms, add the first and the last. 384 plus 138 gives me 522. And then these two, combine your like terms. 192 rad 3I minus 92 rad 3I gives me plus 100 rad 3I. Okay, this is messy. I will not give you something this messy on a test, I promise. So to multiply and add these numbers together, you can use your calculator. So that's going to go up here. 522 plus 100 rad 3I. Add that to this, and we're going to get 150 plus 100 rad 3I, and then this times this. So now I've got -6 plus 4 rad 3I times 150 plus 100 rad 3I. It's -6 times 150 gives me -900. The outers gives me minus 600 rad 3I. The inners gives me plus 600 rad 3I. Notice this is where it starts to feel good. Those will cancel. And then the last, I've got 4 times 100 is 400 times rad 3 times rad 3. That's times 3. So 400 times 3 gives me 1200. They're both positive, but then I'm multiplying by I squared, which makes it negative, minus 1200. Okay, these cancel. -900 minus 1200 gives you -2100. That goes up here, minus 2100. That gives me a 0. And we know that should be a 0 there. Sorry, that looks weird. That should be a 0 there because we know that this is one of our zeros to this polynomial. So when we divide by x minus this thing, we should get a remainder of 0. Okay, so now we've gotten this quartic down to be a cubic. So this represents 1x cubed, this plus this thing x squared plus this thing x plus this constant. But we know that another 0 is this thing. So now I'm going to just build off of here. I'm now going to divide by x minus this thing. So -6 minus 4 rad 3I. Bring down the 1. This is where it gets kind of fun because now I want to do, I bring down the 1, multiply by this, -6 minus 4 rad 3I. Notice these cancel, and I just get a -8. Now multiply -8 times this thing, which is going to be -8 times -6 is 48. -8 times -4 rad 3 gives me plus 32 rad 3I. Those cancel. You get 48 minus 23, which is 25. Now multiply 25 by this. 25 times negative 6 gives me negative 150. 25 times negative 4 rad 3 gives me negative 100 rad 3. And what do you know? That all cancels and you get 0. Okay, so here are two of my zeros. There's one zero, there's another 0. They told you this one. They wanted you to come up with a total of 4, so the other 3. Okay, so this represents x squared minus 8x plus 25. If we set that equal to 0 and solve, we're going to get, I don't think that factors, so x equals opposite of b, so 8 plus or minus square root of b squared, 64 minus 4 times a times c, so that's minus 100 over 2a, so that's 8 plus or minus square root of negative 36 over 2, or 8 plus or minus 6i over 2, or 4 plus or minus 3i. Boom, there's your other zeros. Let's put all our answers together. So this was one solution, this one, and these two. So let's find all other zeros. I'm going to put the answer over here. All our zeros, we've got negative 6 plus or minus 4 rad 3i, comma. We've got 4 plus or minus 3i. So we've got 4 solutions, and all 4 solutions are complex or have an imaginary part. All right, that's all for now. Sorry that problem was so messy. I will see you all soon. Thank you for watching.